Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is count the number of consistent strings. Okay, so the statement goes like this: you will be given a string aloud consisting of distinct characters and an array of words. Okay, and a string is consistent if all the characters in the string appear in the given string allowed. Okay, so in a way you can say that a string is consistent only if it is having the characters which are allowed. Okay, which are in the allowed string. Okay, so let's take one of these examples and try to understand what does it mean by the consistent strings. Okay, let's take this one. So this was your example. So see, the allowed characters are these. Okay, and the characters in the allowed string will be distinct characters. Okay, so there will be no repetitions, and you have to find out the consistent strings in the given words array. Okay, and consistent strings will be those strings uh, whose who which are having characters which are in the allowed string. Okay, for example, if you take this particular one here, b is there in the allowed string, but d is not there in the allowed string. So every character in the particular word should be there in the allowed string. Okay, but this is not the case here, so this is not a consistent string. Okay, so let's explore further. And similarly, because of d, the first one was also not a consistent string. And let's proceed further. Then triple a and b, see, no matter how many times a is occurring, but all the characters of this particular word should be there in the allowed string. Okay, they are there, so we are fine. We got one consistent string at our hand. Okay, then comes the BAA. Then you can see that here also all the characters are present in the allowed string. So we got another consistent string. And similarly here, although it would have been a consistent string, but because of this d, and d not being present in this particular allowed string, it is not a consistent string. Okay, so as you can see, the result also says that you have only two consistent string. Okay, so then this is what you have to return, basically the number of consistent strings in the words array. Okay, so let's see how we can find the number of consistent strings. And before doing that, or before thinking of an approach, let's have a quick look at the constraints also. Okay, so according to the constraints, the length of each word in the length of the whole words array will be of order 10 raised to power 4. Okay, and the allowed length the length of the allowed string will be of order 26, since there are only distinct characters, and it is mentioned that both in the strings in the words array and the allowed string will be only having lowercase English letters. So from A to Z there are 26 characters, and it makes sense that there are saying that at max 26 characters will be there in the allowed string. Okay, because all the characters were distinct in the allowed string. Okay, and the number of characters in the order of number of characters in the each of the words in the words array will be of order 10. Okay, so let's quickly think of an approach. Okay, So the after seeing these constraints and reading the problem statement, a very intuitive approach that came to my mind is, why not convert these strings into something that can be easily then can help us to do the comparison, or checking the consistency of the string in as much as less time complexity as possible. So I was trying to achieve order of one time complexity for checking consistency of a word. Okay, for checking consistency of a word. So see, in the problems like this, you should be thinking of that what kind of structure we would be able to store our words into. Okay, so since this is the major hint in the constraints, that's why I stress upon reading the constraints, because first that they help you in thinking of the optimal approach straight away. Otherwise you may end up your time wasting your time thinking of an approach that might lead you to the time limit exceeded error, and your solution will not be accepted. Okay, the very next thing is then they can give you subtle hints that you know what kind of approach will work out here, or what kind of optimal tricks you can use. Okay, so as it is mentioned that there are only there are only lowercase English letters allowed. Okay, in both the allowed string and the strings in the words array. Okay, so how many of those are there? uh, A to Z, there are 26 only. Okay, so 26 characters can be there in the 26 distinct characters can be there in both of these cases, allowed string and any of the strings in the words array. Okay, and we also have a 32-bit integer of integer data type. Okay, and if each bit is corresponding representing one of these characters, then uh, 32 bits are more than sufficient to represent 26 characters. So what I mean to say is, see, let's take one of these examples. Let's take the very first one, AB. Okay, if the given string is A and B, so we will be traversing the string character by character and picking out every character each time, doing the traversal from left to right. Okay, so see, the first character is A. The thing here is to be noted is we are taking relative difference of each character from small a. Okay, so a's distance or difference from itself will be 0, and similarly b's distance from a will be 1, and it will continue like this. Even if you have z, then its relative difference with respect to a comes out to be 25. So see, from 0 to 25 you can have a mapping. Okay, so if these were the characters, let me change color here. So if these are the characters, then they can be given corresponding numbers. Okay, or numbers you can say. So these numbers are their relative positions with respect to small a. Okay, so how far they are from small a. Okay, so z is 25 characters ahead of small a, so that's why its corresponding number was 25. Okay, so now comes the question that I was saying, that we would be able to store these numbers basically in the bits. So see, if we are talking about a 32-bit integer, let's take a fresh slide for that discussion. So going from right hand side and considering the first bit as the 0th bit. Okay, we would be having, and if we are even considering a signed integer, then we would be having from 0 to 30th bit we can use, and the last bit can be MSB, most significant bit, which is used to represent the sign of the number. Anyways, we are not having any negative sign number, and our range of characters is can be very well fitted between this 0th to 30th bit position. Okay, so these are bit positions basically. Okay, so now question arises, if AB is given you as the string, then how can you represent it as a integer? Okay, by adjusting its characters in the bit positions of a 32-bit integer. So let's see. For A, we will be seeing what is the relative difference of A with respect to small a integer wise, and it comes out to be 0. And for B, this difference comes out to be 1. Okay, now you will be taking in an integer 1, and you will be doing a left shift operation. Okay, so basically 1 can be represented like this, and this being the 0th bit. Okay, or bit position you can say, to be more specific. Okay, so you will shift 1 by the number of real this uh, let's say this number is x, or num times. Okay, number is nothing but relative position of a with respect to small a. Okay, relative position of a or a character of a character with respect to small a. Okay, so you will shift one left shift one those number of times. Okay, so since it was 0, so if you want to shift this 0 number of times, it will remain here only. Okay, so it will be 1 only. Okay, so binary representation will remain like this. Okay, now you will be starting with a mask. Okay, mask will having initially all the bits set to 0. Okay, so here I am taking only 4 bits from right hand side, because that they will be sufficient. Otherwise, you can take up to 0 to 30th bit. Okay, while thinking of a representation of a particular binary number. Okay, so what we will be doing here is we will be doing a OR operation. Okay, so mask initial state is this. Then for A, we generated a mask kind of. So A's mask. Okay, came out to be 0001. Okay, and you will do a OR operation of the original mask and A's mask. Okay, and now the original mask will become this. Okay, I hope till now it's clear. Then you come to the second character, which happens to be B, and relative difference or relative difference of B and small a comes out to be 1. Okay, because B is 1 ahead of small a alphabetically. So then you will shift this 1 by 1 number of times. So this time this 1 will actually be shifted to this particular position, and your binary representation corresponding to B or B's mask will be looking something like this. Okay, now this is your current value of this mask. Okay, and you will be doing a OR operation of these values, and this was B's mask. Okay, so let's do our OR operation. Okay, So after doing the OR operation, your final value of the mask become this. Okay, and this can be represented in the form of an integer. So this is 2 and this is 1, so it is equivalent to 3. Okay, because of the bit positions 2 raised to power 0 and 2 raised to power 1, so these two positions were set, that's why it came out to be 3. So see, 3 is representing AB. So this is how you are able to convert each of the given numbers to a 32-bit integer mask. Okay, so it is that simple. And once you have a solid understanding of this type of technique can be applied to many scenarios. This is one of those scenarios. So what we will be doing is we will be generating masks for allowed string and each of these words. Okay, so let's take a fresh slide for that discussion. So we will be generating masks for all of the strings, okay, in words array and allowed string. Okay, so once you are having those masks, you will be doing a comparison, and the comparison will be in just order of one time complexity. How will that be possible? Let's say allowed string is represented by a mask, a mask. Okay, and each let's say there is a word in the words array. Okay, it is represented by word mask. Okay, so see, if all the characters of word are there in the allowed string, that it means that if you do a or operation of a mask with word mask, then it the result should be equal to a mask only, because what will happen is if there are any extra characters in the word mask, so those will you know set some extra bits that are already set in a mask. Let's say a mask was like this. Okay, only uh, a single one. Okay, binary representation of a mask, and your word mask is something like, let's say, this. Okay, so there is one extra bit set. When you will do a or operation of these two, it will be this, which is by the way not equal to this original a mask. Okay, so that is why you would be able to know whether all the characters in the given word were present in the allowed string or not in a instant. Okay, and it will be in order of 1. Okay, although for making mask we would be requiring some time complexities, but we are saving some uh, extra computations here if we have not taken this kind of approach. Okay, so let's see the implementation and then we will be discussing about the complexities. So this is the implementation. Okay, it's a pretty short one, and let's have a quick discussion of it. Although we have covered most of the things in the approach discussion only, but anyways we will be covering them again. So as I talked about that we will be generating masks for the allowed string and each of the words in the words array. Okay, and then thus doing a or operation and checking whether the allowed mask whether that or operation is resulting equal to the allowed mask. In that case the word is consistent. Okay, so let's see how we are converting each of the strings into mask. Okay, so as we discussed, we will be starting with a mask of all the bits set to 0. So that's why starting with a 0 integer value. And then in the given string, we will be processing the characters word by word. Okay, and for each word, we would be interested in finding the relative difference of that character. For each character, relative difference of that character with respect to small a. Okay, and then we will be generating mask for that character. Okay, mask for current character. Okay, and then we will be doing OR operation of the whole mask, that is representing the string mask and the character mask. Okay, and at the end of this whole operation, you will be having a mask equivalent to the string. Okay, representing the string. And then uh, rest of the operations we have already discussed. Then we will just do our operation and check whether it was equal to the original allowed mask. And if it is, then the current word is the consistent word. It indicates basically that all the characters that were represented by bit positions in an integer still remains same in the allowed mask, even if we do a OR operation of the word mask and the allowed mask. Because if the OR operation is keeping the all the digit this particular bits same, so had it been instead of 1 1 only 1, something like this, we would have said that okay, we are good to go. The current thing whatever you are having, what you are having is consistent. Okay, so in that case, we will increase the consistent string count and simply be returning that consistent string count. Okay, so now let's have a discussion about the complexities. The time complexity wise, if there are n words, size of the words array is n, and let's say each word is of order m size. Okay, so word size happens to be equal to order of m, then this particular loop will run for order of m. Okay, and this order of m running of loop will be happening n times, order of n times. So overall time complexity comes out to be n into m. Okay, and let's see the space complexity. Space complexity wise, see, uh, everywhere we are just using couple of integer variables and they do not take up any extra space, and this thing is also any not a recursive function. So space complexity wise we can say that we are constant. Okay, or order of 1. So this is the whole approach and the code. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. And until next time, keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.